Okay, so for this video note, we are going to practice actually calculating potential and kinetic energy. So we're going to do a bunch of math problems today. So if you could make sure you open up your Google Doc that has all of the math practice problems, you can either type up and show your work on the Google Doc, or you could print it and hand write your problems. But I want to go through some examples first before we actually go through your practice problems. So remember that yesterday we learned about kinetic energy, a moving object, and we learned about potential energy, which is an object above the ground but not moving. And so remind you of your formulas. Kinetic energy equals 1/2 times your mass times your velocity squared. Don't forget that squared. And potential energy is your mass times gravity times height. So I'm going to do this two problems, and then we're going to go through our math practiced worksheet. Okay, so we have a 15 kilogram object and it's moving at 10 meters per second. What is the object's kinetic energy? So I'm giving you the fact that it is a kinetic energy formula. You might not always get that in your practice problem. So remember the formula is Ke equals 1/2 times m, which is mass, times velocity squared. So first we need to identify what the m and the v is. So if you look in your problem, you can know that kilograms is a mass number. So your m equals 15 kilograms. And then what is your velocity number? Well, remember velocity is speed. So that's distance over time. So I need a distance over time unit. So that's going to be 10. So 10 meters per second. Now we need to square that number. So 10 squared is 100. All right, so then you want to plug that into your chemical equation. So Ke equals 1/2 times 15 times 100. Now, the best thing to do is to put your m and your v number, multiply those first. So do 15 times 100 to get your that number combined. So now it's Ke equals 1/2 times 1500. Now you can either take that, you can either go 1500 and do divided by 2, or you can multiply it by 0.5, however you want. But if you do 1500 divided by 2, you should get 750 joules. That's how much energy, that's how much kinetic energy is in an object that has a mass of 15 grams and is moving at 10 meters per second. All right, so let's look at a potential energy problem. So if we have a 6 kilogram ball that is 5 meters off the ground, what is the object's potential energy? So remember, potential energy is mass times gravity times height. So if we want to find all of those numbers first. So we need to find the mass number, so we're looking for a kilogram number, so that would be 6. And remember, gravity is always going to be 9.8. Always. G will always be 9.8 because we're talking about gravity of Earth's pull, and we're on Earth. So, and then the height, you should look for a meters number. So that would be 5. So now we just plug that into our formula. So Pe equals 6 times 9.8 times 5. And you just multiply all those together, and you should get a number that has joules. So don't forget your J. So it would be 294 joules is the potential energy that object has if it weighs 600 kilograms and is 5 meters above the ground. All right, so go and open up your PE and KE practice Google Doc to work through the practice problems. And I'll go through number 1 with you again, just in case. So it says number 1, you serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand with a speed of 30 meters per second. The ball has blank energy, and now calculate it. So remember, we have to ask ourselves a question. Is the object moving or not? And it says it is moving because it's giving you a speed number. So we know that is kinetic energy. So we need to calculate the kinetic energy using the kinetic energy formula. So Ke equals 1/2 times m times v squared. So remember, to show your work, I really want you to show me what the m number and the v number is, and then plugging them into the formula. So m is 2.1 kilograms, because that's where it says up there kilograms is our mass number. And then our speed number would be the velocity, because remember, velocity is just speed in a direction. So it's 30, but don't forget we have to square it. So that would be 900. So plugging them all into your formula, you have Ke equals 1/2 times 2.1 times 900. So essentially, remember, put 2.1 and multiply that by 900. Put your mass and velocity multiplication together first before you divide. So it would be 1/2 times 1800. So you could take 1800 divided by 2, and you would get 945 joules. Do not forget your joules unit. All right, so what I would like you to do now is take an opportunity to try and practice those problems on your Google Doc. And then the next step after you've done a couple of practice, I would like you to go to the daily formative assessment for today's date, and there will be a couple of practice problems in there as well. Please use these notes. Please use the process when you're filling out those questions.